Hello everyone, welcome to another video on solving a LeetCode problem with APL. Today we're going to tackle or start tackling some of the requests I have on the GitHub repository where I host all of the solutions. So as we can see, there's been a couple of requests here, and I think I'll just start from the bottom. And I was taking a look at the problem names, and problem 2 on LeetCode is called add two numbers, and this sounds deceptively simple, but then it's a medium problem, so I think it could be interesting to solve this one. So yeah, let's go ahead and open it and read the problem statement and see what we must do. Oh, okay, linked lists. Okay. So it says we are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contains a single digit. Add the two numbers and then return the sum as a linked list. You may assume the two numbers do not contain any leading zeros except the number 0 itself. Okay, so what's this? 7. Oh, I see. So these are just the digits. So this represents the number 342, and this represents the number 465, and the result is 807. And the linked list is just in the order of how you would do the addition on paper. Right, okay, so this makes sense. So let's see, what do I want? I want to show you this. So my interpretation of this is that if we have, so this is 342, so if I had to do a 342, sorry about that, 4 plus 465, I start with the units and then the dozens and then the hundreds, and this is, so we go from right to left, and this is exactly the order of the linked lists. So it's essentially telling us to sum digit by digit and just be careful about carrying things over. Right, so I think that this will end up much more simple in APL because there's no obvious way in which you would define a linked list. I mean, this sounds like a weird requirement, so let me just see what they would do in Python, just so I can get a feeling for what's the equivalent I should go for. So list of nodes. Right, so it's just we can work with a regular list and abstract away the requirements to skip numbers and to fetch the next node and whatever. So let's see, one of the linked lists, so let's say on the left, is going to be 243, and on the right we're going to get 564, and we just want to add these. And there's plenty of ways in which we can do this. So let's see, we can add them together, and so we can add them together, and this is kind of like the tentative result, right? But then we need to be careful about carryovers. So if we do modulus 10, we get the digits, the units in each place, and at the same time we can check. Let's see, we can get the ceiling or the maximum between 0 and the result minus 10. Wait, so give me a second. So this is the result. Right, so this is not what I want. What I want is to round down the division by 10. So these are the carryovers, and then what I can do is shift them one place to the right. So drop the last one and append one to the top, and then add this to the remainder of the result. And this seems about right. I'm just afraid that in the process of carrying, of computing the carry, I might need to recompute the carry again. So for example, what I mean is, suppose that on the left we have, let me think, like 3, 4, 5, and on the right we have 3, 5, 5. Yes. When we sum these together, left plus right gives this, but this is the last one, so maybe not the... Oh, and this also shows another weakness. So as of now, if I have a carry over there, yeah, this wouldn't work because I'm assuming that the last digit is not a carry, and we might need to extend the solution because this addition here would result, or the result here is 1000 and something, so we need a new digit there. But actually the issue I was going for, so let's solve that after. The issue I was going for is, if this is my input, left plus right gives this, so there's a carry here, and when I take the carry and add it to the right, now this needs to carry. So there's an arbitrary number of carries I need to consider. Well, not completely arbitrary, just up to, I might need to chain this update as many times as there are digits here. So I might need to repeat the carrying updating thingy. So how can we do that further? And actually, let me just, there's a short tangent here. There's an obvious solution, and that is if we consider this primitive, we can just add the two numbers together, so we can add left and right over base 10 conversion, so 10, and then we can split again. And then we just need to wait, so we need to flip after converting, and we need to flip again. No, sorry, not after converting. We need to flip before converting because the digits come in the reverse order. So we flip, we sum, and then we split, and then we flip again. So let's see, left, right, yeah, and the result here will be 800th. Right, so this is like an obvious solution using the 10 decode, but I think the decode function, but it feels a little bit against the purpose of the problem. So I think we can try to push, I think I can try to push forward or push through with the other solution. So for the other solution, the basis is doing the left plus right, but we can only do that after making sure that both left and right have the same number of digits. So let's see if they have an example where, yeah, exactly, they have an example where the two linked lists have different lengths. So the first thing we need to do is make sure that both of the, so let's edit the solution. Both the left and the right arguments have the same length. So the maximum length is the left maximum over the length or the tally of the right one. So this gives us the maximum length, and then the left one, let's make sure it has enough digits, and same thing for the right one. So this makes sure that both A and W have the same, or the same number of digits. Then we can add them, which is what we've done here, so the left plus right. And now we need to take care of the carries. So let's write a short function that updates the carries, and then we apply it while we are making changes. So how would we do that? Well, let's see, where's the carry update I did. So this was the carry update. So the carry update takes the result and divides by 10. So these are the carries. And now we need to shift them to the right. And when we do that, we might be when we shift them to the right, we are introducing, or we are making this longer than W, or than omega, sorry. So when we add the carries, we also need to make this number longer. So now what we do is we take the carries and add them to this. So this extends the result to have a 0 digits there. So what we do is we update the carries until there's nothing else to update. So let's see what this does. It feels more or less fine, except that I doubt I got this right on the first try. So let's see, left solution, right. So what's CS and what's 10 result, 0. Where did I take this from? It's obviously not result there. It's the omega is what we have so far. So again, left solution right. Oh, amazing. And now this is an infinite loop because I'm always extending. So even though there might be no carries, I'm making this longer. So what I need to do is, if there's any carries in CS, I want to do this. I want to extend. If not, I want to return my original value unchanged. This is an example, and then one way to finish this is by removing trailing zeros. And in order to remove trailing zeros, what you do is, or what you can do is, for example, compare 0 with V. This is a terrible example because it's symmetric, so it's harder to see what's happening. So let's pretend that's V. So you compare V with 0. Then you flip it. And then you do an AND reduction. No, sorry, an AND scan. You flip it again. And now this is a mask of the values you want to remove. Or in other words, the negation is a mask of the values you want to keep. So this way, this is like almost an idiom. This is a phrase that helps you when you need to remove trailing things. So we can go ahead, edit the solution, and remove trailing things from here. So this is V, so V compress with a negation of flip of the AND scan. Where is this? I never know where this is. It's over there. The AND scan of the flip of 0 equals V. So now left, sol, right, gives 800, and now let's test it with the other test case. So a bunch of 9s. So a bunch of 9s here, sol 1, 2, 3, 4. That should give 8, 3 9s, 8, 3 9s, 3 zeros and a 1, 8, 3 9s, 3 zeros and a 1. So this seems to be correct. Now, is it decent? Well, to be honest, I don't love the condition here. So maybe this could be, instead of checking a condition, this could run a specified number of times instead, which will be n, because we know n times is enough. So that's also fine. Now, is this absolutely correct? Let's see, let's add a 5, 4, 4, sol 5, 5, 5. Yeah, exactly. So this is the updates on the carry are being computed the correct number of times. So there you have it, a solution to problem 2. I hope this was not too long for you. If you have an alternative solution, feel free to comment it. Probably YouTube will delete your comments, so maybe go to the repository where I'm hosting all the solutions. See you for the next one. Bye.